Hello students, welcome to YouTube channel Vidya for Success. Dear students, in this video let us study the concept of frequency polygon. So what is a frequency polygon? So it is one of the important type of graph. So how are you going to represent this particular graph, or which particular type of distribution, frequency distribution we can consider this? So the frequency polygon can be considered for both continuous as well as for discrete frequency distribution. Okay, so even if the distribution is discrete or if it may be a continuous one, for both the type we can plot a frequency polygon. So how the graph or else frequency polygon will look like? So it will be of this nature. Okay, so there are two different methods of constructing a frequency polygon, but this is how it looks at final stage. So here this particular graph, as you can notice, there are multiple sides. Okay, there are different sides are there. That's why it is referred as a plane geometrical figure having multiple sides, which can be referred as polygon, multiple sides. Okay, so what is the area, what is the total area under this particular polygon? So the total area is directly proportional to the total frequency. Okay, so the total frequency given will be directly proportional to the area falling under this particular polygon. Next, as I said earlier, frequency polygon can be plotted for both continuous as well as for discrete frequency distribution. So let us take the case of discrete frequency distribution. How to plot for discrete frequency distribution? So please notice here. So this is the graph representing a frequency polygon for discrete frequency distribution. So what do you mean by discrete frequency? So here we will be having a variable taking a value. Okay, we will not be having a set of values, I think, but we will not be having a range of values. Now, for example, we will not be having 0 to 10, 10 to 20, 20 to 30. No such variable values will be there. We will be having only one value. So if a variable picks a value within the given range, then that is referred as a discrete variable. So if a distribution is of such a variable, then that is referred as discrete frequency. Okay, so now we are plotting a discrete frequency distribution. So how are you going to consider a frequency polygon? So to construct a frequency polygon of discrete type, we will be considering the discrete variable along the x-axis. So discrete values will be taken along the x-axis, and the corresponding frequencies are considered along the y-axis. Very simple. So in case if it is a discrete frequency distribution, the variable values, the two discrete variable values, they are considered under the x-axis. In the y-axis correspondingly, we will be considering their frequencies. Once we get these points, these plotted points are joined by a line segment, that too a straight line segment. So we need to consider a straight line segments. By using a straight line, we can join all these line segments, all these plotted points. When all these plotted points are joined, we will be getting a frequency polygon. So this is what happens with the discrete frequency distribution. Now in case of a continuous frequency distribution, we will be following two different methods. So the two different ways are there in order to construct a continuous frequency distribution. So the first method, so here please notice here is the first method. So first we will be constructing the histogram. Please notice here. So if we are in following a first method, first case, we will be first erecting rectangular bars, nothing but first we will be considering the histograms. After plotting the histogram, later the midpoints of the upper rectangles, please notice here the midpoints of the upper horizontal lines, as you can notice here, not the bottom one, they are the upper horizontal lines. These midpoints, they are first of all marked. After marking them, these points are joined by a line segment. Okay, so please notice here. So what is the midpoint for 0 to 10? The midpoint is 5. What is the midpoint for 10 to 20? Midpoint is 15. Next, for the midpoint for 20 to 30 is the midpoint is 25. So these midpoints, first of all, we will be joining them. So after joining these midpoints, we will be drawing a line segment. Okay, so if we draw the line segments, we will be joining from, for example, 5 to 15, next 15 to 25, 25 to 35, 35 to 45, like this we will joining up till here. Then what happens with the the last ends? the endpoints of the broken lines, what are you going to do with them? So if you leave it here, then you will not be going to get a closed area. Okay, so these, the endpoints of the broken lines are joined to the baseline, nothing but they need to be joined to the x-axis. But how and where they will be joined? So they will be joined to the baseline at a midpoint of imaginary class. What do you mean by imaginary class here in this case? So 0 to 10 is the first class, followed by the 10 to 20. So what will be the class, imaginary class towards the left side of this 0? So the origin, so the imaginary may be 0 to minus 10, maybe the imaginary class. So in this particular imaginary class 0 to minus 10, what will be the midpoint? Midpoint will be minus 5. So we will be first of all making a note at minus 5 and joining the points from minus 5 to 10, sorry, minus 5 to 5. I will be joining them. Similarly on the either side, this side also. So 70 to 80 is the last class, and what is the imaginary class towards the right hand side? 80 to 90. So here the midpoint is 85. From 85 to 75 we will be joining a line segment which will join the x-axis. So if there are broken ends, they need to be joined so that we get a complete area. Okay, so this is how we will be drawing a frequency polygon using the first method. That is, first we will be constructing the histogram, later we will be joining the midpoints of the upper rectangles or midpoints of the upper rectangles by a line segment, and later the broken ends will be joined to the x-axis by considering the imaginary classes, again class intervals. So this is the first method. The second method, we won't consider the histogram. We will not be wasting time by plotting the histogram. Directly, even if it is a continuous class interval, directly we will be considering the midpoints. First, midpoints will be noted and these midpoints will be marked. Later, we will be joining them with the line segment. So what happens with the second method? By joining the plotted points by the line segment, taking the midpoints of the x-axis. Let us say, so for example here 45 is the midpoint, so later on 55 is another midpoint, 65 is another midpoint. These midpoints are directly joined. Instead of considering the histogram, directly we will be choosing the midpoints. For example, if the class interval is let us say 10 to 20, what is the midpoint? Midpoint is 15. So against the midpoint we will be considering the y-axis value, that is the frequency. So once you consider frequency, we will be getting the exact point where we need to be noted. Later it can be joined. Okay, so this is how. Okay, the same concept will be followed here also. If there are any broken lines, these broken lines need to be joined to the x-axis. How they are joined? Just like the earlier case. Okay, you will be considering imaginary class intervals. For the imaginary class interval midpoints, we will be joining these line segments. Okay, so totally there are two methods or two ways or two cases that can be followed for continuous frequency distribution. Now let us consider the example, the first example here. We have been asked to draw a histogram and then obtain frequency polygon from histogram. Okay, so here we have been given the table frequency distribution. As you can notice here, 100 to 150, 150 to 200. What type of class frequency distribution here we are having? We are having a continuous frequency distribution. Okay, 100 to 150. So complete all the values within the ranges will be considered here, 100 to 150. So it is a continuous one. So and followed by that we have also been given the frequencies. Number of workers are frequencies, 7, 19, these are all the frequencies. Let us solve this particular problem. So this is how we will be going to get a frequency polygon. So first what we need to do, first we need to consider the histogram. So for the class interval 100 to 150, so in the x-axis we will be considering the class interval, in the y-axis we will be considering the frequencies. So first we need to consider the scale. So x-axis, how I have considered the x-axis, 1 centimeter is equal to 50 rupees. Okay, what about y-axis? 1 centimeter is equal to 5 workers. So 5 workers, 10 workers, 15, 20, 25. So here we have started from 0. So 50 rupees, 100 rupees, 150 rupees, 200 rupees, it goes on up till 450 rupees. Okay, so why 450? Because the final limit is 400. That's why I have gone up till 450. Next, followed by that, the first class interval is 100 to 150. So for 100 to 150, I need to erect the rectangular bar because it is a histogram. First, we need to draw histogram. So what is the number of workers? The number of workers are 7. So here I will be drawing the first rectangular bar. Followed by 150 to 200. How many workers? 19 workers are there. So here I will be erecting the rectangular bars. Similarly, for all the class interval, I will be erecting the rectangular bars directly proportional to the complete frequency. So followed by that, half of the work has been done. Now we need to plot the midpoints. We need to identify the midpoint. So for 100 to 150, the midpoint is 125. So for 150 to 200, the midpoint is here 125. 175 is the midpoint. For 200 to 250, the midpoint is 225. So first we will be identifying the midpoints. We'll be making a marking here. Okay. After making a marking, we need to join them by a line segment, straight line segment. And what about the broken end lines, end points? These broken end points need to be joined to the x-axis. For that, we have to consider imaginary class interval. So 100 to 150 is the beginning class interval. So what will be the previous one? The previous one will be 150 to 100 because the width is 50-50. So if the final class interval here in the given problem is 350 to 400, what is the next class interval? 400 to 450. So what is the midpoint for 400 to 450? 425. So we will be joining at the midpoint 425 these ends. So at here it will be joined at 25. So this is how we are going to plot a frequency polygon. Second problem. Draw a frequency polygon to the following discrete frequency distribution. Please notice here, first of all, they have asked us to draw frequency polygon. Okay, directly, not going by histogram, then frequency polygon. No, directly we need to plot frequency polygon. And what is the given data? Given data is in terms of discrete frequency. Please notice here, there is no class interval. Directly 70, 80 like this. So this is a discrete frequency distribution. So we will be considering the scale first. So x-axis 1 centimeter is equal to 10 IQ. What about y-axis? Y-axis will indicate frequency. 1 centimeter is equal to 5 children. So 5, 10, 15 children, 20 children like this. So these x-axis are indicating the IQ. So the question, IQ starts with 70. So since it starts with 70, you need not have to consider we need not have to go by 0. Okay, we can right away start with 70 because if you start with 0, 10, 20, 30 like that, so you will be leaving a lot of space. So better you start with, if you can consider this origin as 0 and you can write a zigzag line and you can start with 70. Okay, that will be explained later on. Now it is not in the topic. So you can start with 70. Let it be. So for the 70, for the variable 70, what is the frequency? The frequency is 7. So we will be first making a mark here. Next, for the variable 80, what is the frequency? 19. Again, we will be making a mark. For the frequency 90, the frequency is 27. For the frequency 100, it is 15. For frequency 110, it is 12. So for all the frequency variables, we will be making the markings here. Okay, for the variable 110, it is 212. For the class interval 120, the frequency is 8. So after making all the markings, we will be joining them by a straight line. It's very important. You need to join them by straight line. So if you join all these straight lines, we will be getting a half of the work done because still we need to join these broken lines. So broken line need to be joined. So from here we will be joining it to the midpoint of the imaginary line. But there is no midpoint. Why? The reason here is, what is the reason? Because we are not having class interval. If we had class interval, then we would have gone with midpoint. But there is no class interval. So what is the imaginary limit then? So there is what is the width for all successive limits here? Variable 70, 80, 90. There is a width of 10. So what will be the imaginary limit before 70? 60. So we need to join at 60. So we'll be considering this point as 60. And what about this right hand side? So 120 is the final variable value given in the question, but we will be considering another imaginary limit, that is 130. So we'll be joining this open end at 130 to the x-axis. So by joining them, we will be getting the frequency polygon of children's IQ. So the total area within this particular polygon is equal to the total frequency. If you add all the frequencies, that is 7 plus 19 plus 27 plus 15 plus 12 plus 8, that would come entire value will be identified as a total frequency. This is the total area, which is equal to total area. So this is how we are going to plot the frequency polygon. Thank you.